Hello everyone, thank you for having me today. My name is Rahul Sukaralte, studying first semester MBA at Mizoram University. Today I'm going to have a presentation on index numbers. So at the table of content, as a first topic we have introduction. What is an index numbers? An index number measures the relative change in price, quantity, value or some other item of interest from one time period to another. A simple index number measures the relative change in one or more than one variable. An index number is a statistical measure designed to show changes in the variable or group of related variables with respect to time, geographical location or other characteristics. Characteristics of index numbers. Index numbers are specialized average. Index numbers measure the change in the level of a phenomenon. Index numbers measure the effect of change over a period of time. So let's jump right into the definition. According to T.W. Wannacott and Ronald J. Wannacott, an index number is a single figure showing how a whole set of related variables have changed over time to time, of different from place to place. According to Dr. A.L. Bowley, a series of index number is a series whose affects in its trend and fluctuation the movement of some quantity to which it is related. Wessel Willett says an index number is a special type of average that provides a measurement of relative change from time to time or from place to place. Type of index numbers. So this is the four main types of index numbers. Price index. Price index numbers measure the relative change in the price of a commodity between two periods. Prices can be either retail or wholesale. Quantity index. These index numbers are considered to measure changes in the physical quantity of goods produced, consumed or sold for an item or a group of items. Value index. Value index numbers study the changes in the total value of a certain period with the total value of a base period. For example, the indices of stock in made, purchase, sales profit, etc. are analyzed here. Composite index. It measures the average relative change of a group of variables related with respect to a single base number. It is determined from a group of different items. Limitation and uses of index numbers. Here in the limitation of index numbers, we have the indices come out as a result of samples. These samples are mostly deliberate. As a result, there are valid chances of error to swipe directly. Avoiding or preventing this error can turn out to be a difficult job. Index numbers are always based on items. Most of the times, these selected items show off the trend, thus hiding off the real story and the picture. These are numerous methods that we use for the proper constructions of index number. As a result of this, the outcome brings different values which are likely to create a lot of confusion. As long as these limitations are taken care of, there are several areas that bring out the uses of an index number in statistics. So here in the uses of statistics, as long as these limitations are taken care of, there are several areas that bring out the uses of an As long as these limitations are taken care of, there are several areas that bring out the uses of an index number in statistics. So here in the uses of index numbers, we have index number have a great use in deflating. Index numbers have the capacity to adjust the primary data at different costs. Therefore, it becomes easy to transform a nominal wage to real wage. Index numbers come up with several trends and tendencies that help with making important conclusion in cyclical force and irregular forces. We also use index numbers in areas like economics. Index numbers help with framing the simple and suitable policies by providing guidelines. These guidelines also help to make decisions relating to research, questions, and so on. The use of index numbers helps in tackling The future in the future enhancement of the economic activities. Most people use it in time series analysis to know more about the cycle development, trends, and variation, etc. Index numbers measure the change happening in the standard of living over a given period of time. For the last topic, we have method of constructing index number. The figure below shows the method of constructing index numbers. Index numbers can be divided into two parts, unweighted and weighted. In unweighted, we have simple aggregatives and simple average of price relative, and in weighted, we have weighted aggregated and weighted average of price relative. Simple aggregative method. It consists in expressing the aggregate price of all commodities in the current year as a percentage of the aggregate price in the base year. So here we have P01 equal to sigma P1 divided by sigma P0 into 100, where P01 stands for index number of the current year. P1 is equal to total of the current year price of all commodities, and P0 is equal to total of the base year price of all commodities. So for an example, here we have, from the data given below, construct the index numbers for the year 2019 on the base year 2020 in the state of Mizoram. We have commodities, units, price in 2019 and price in 2020. So here we have summed up all the price in 2019, and we have sigma P0 is equal to 3,236, and in the same way we have summed up price in 2020, and we have P1 is equal to 4,351. So index number for 2020 is equal to P01 is equal to sigma P1 divided by sigma P0 into 100. So here we have 4,351 divided by 3,236 into 100, and then we have 134.45. So this means that the price in 2020 were 34.45% higher than the previous year. Simple average of relative method. The current year price is expressed as a relative of the base year price. These price relatives are then averaged to get the index number. The average could be arithmetic mean, geometric mean, or even median. So here we have P01 is equal to sigma bracket P1 divided by P0 into 100 closing bracket divided by n, where n is the number of items. So here is an example. From the data given below, construct the index number for the year 2020 taking 2019 as by using arithmetic mean. We have commodities, price in 2019 and price in 2020. So here is the solution. Index number using arithmetic mean. So here we have price relative, where P1 divided by P0 into 100. So we have summed up all the price relative, and we've got 603.37. So P01 is equal to sigma bracket P1 divided by P0 into 100 closing bracket divided by n. And we have 603.37 divided by 5, and it comes out 120.63. Weighted index numbers. These are those index numbers in which rational weighted are assigned to various chains in an explicit fashion. Weighted aggregative index number. These index numbers are the simple aggregative type with the fundamental difference that weights are assigned to the various items included in the index. So here are the several different methods: Durbis and Bowley's method, Fisher's Idle method, Marshall-Ashworth method, Laspier's method, Patch method, and Kelly's method. Laspier's method. This method was devised by Laspier in 1971. In this method, the weights are determined by quantities in the base. where P01 is equal to sigma P1 Q0 divided by sigma P0 Q0 into 100. Patch method. This method was devised by a German statistician Patch in 1974. The weights of current year are used as base year in constructing the patch index number, where P01 is equal to sigma P1 Q1 divided by sigma P0 Q1 into 100. Derby's and Bowley's method. This method is combination of last year's and patch method. If you find out the arithmetic average of last year's and patch index, we get the index suggested by Derby and Bowley, where P01 is equal to sigma P1 Q0 divided by sigma P0 Q0 plus sigma P1 Q1 divided by sigma P0 Q1 divided by whole divided by 2 into 100. Fisher ideal index. Fisher ideal index number is the geometric mean of the last year's and patch index numbers, where P01 is equal to root over sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1 into 100. Marshall-Ashworth method. In this index, the numerator consists of an aggregate of the current year price multiplied by the weight of both the base year as well as the current year, where P01 is equal to sigma P1 Q0 plus sigma P1 Q1 divided by sigma P0 Q0 plus sigma P0 Q1 into 100. Kelly's method. Kelly's thinks that a ratio of aggregate with selected weight gives the base index numbers, where P01 is equal to sigma P1 Q divided by sigma P0 Q into 100. Q refers to the quantities of the year which is selected as the base. It may be any year exists base year or current year. Value index number. Value is the product of price and quantity. A simple ratio is equal to the value of the current year divided by the value of base year. If the ratio is multiplied by 100, we get the value index number. So V is equal to sigma P1 Q1 divided by sigma P0 Q0 into 100. Weighted average of price relative. In weighted average of relative, the price relative for the current year are calculated on the basis of the year price. These price relative are multiplied by respective weight of items. These products are added up and divided by the sum of weight. Weighted arithmetic mean of price relative. P01 is equal to sigma PV divided by sigma V, where P is equal to P1 divided by P0 into 100. P stand for price relatives and V stand for value weight, which are P0 into Q0. So that is all for my presentation on index numbers. Thank you.